Okay, we're back after the Meridian tour. Um, just kidding, we haven't done it yet. In the future. Um, anyway, so that was the Meridian CS1000 Switch that I just showed y'all. Fully populated with all of the cards. So I was probably talking about the call pilot and saying something about um, still need a password to it. Yeah, Windows 2003 box. That thing's going to be fucking isolated from the internet. Anyway, let's get let's get here. Let's get to what everybody wants to know. How the fuck do you do this kind of shit? And how do you configure a Meridian CS1000? Well, I'm not going to do it from scratch because that would take 2 to 3 hours, and I would have to flush all my hard work down the drain. I mean, no, I wouldn't, because I could just EDD it and bring everything back. But I've never done that before, and I don't want to do that today. I have backups, but I don't want to have to go through restoring them because, Jesus, that's a fucking pain in the ass. Um, Anyway, so what we start at is the IIA, or Avaya. I'm going to call it IIA the entire time. The IIA Nortel Element Manager login right here, the security server. So I'm going to log into it, and we're going to go straight to the Element Manager. What we got here is just, information about the system. Nothing special. So we're going to go through pretty much everything here on the side, and I'll explain why and how it's set up, um, and what links into what to make what work. So we're going to skip alarms and virtual terminals. Virtual terminals is just like a Linux terminal. If I need a Linux terminal to do any not Linux terminal, if I need a CS login, I go into the Linux terminal for the signaling server, log in that way. It does an R login straight to the terminal of the CPPM, the pulse. We're going to start with core equipment loops. So loops, everybody needs a loop. So loops are basically services. Imagine them as services. So you have to have a tone and digit switch because that's what you switch the electronic switch network on, the TDS. So you have to give it a loop number. I gave it 104. It's just any arbitrary number 0 to 255. There's reasons I picked everything. The reasons are suggestions from where I learned all of this stuff. Good old Mike's PBX cookbook. Great website. I will be linking it below. It has a start to finish guide on how to get running on the CS1000. It is what I follow when I'm bringing it out, because if you do not follow it to the letter, it just won't work. It's one of those things that if you don't do things by the book, things will just not fucking work. Anyway, so the tone digit switch loop number I put as 104, and then it wants my IP media gateway. So my IP media gateway is just my super loop and shelf. We will get to super loops later. So the super loop I chose was 004. That is, the super loop is my MGC. MGC is the first card in a CS1000. It basically houses and addresses the shelf. So the shelf being 0, because this is an option 11 shelf. It's very small. It's a small system, not a large system. God, if I had a large system, it'd be about twice that size, and I would need at least a cabinet just as high, maybe 3 stacked. It'd be fucking awesome to have a large system, but no. So we're going to cancel that. And then we have a conference loop, which is same thing, that except for it's used for addressing conference lines. Also needs a media gateway address. And then we've got 106 here. 106 is special. 106 is my foreign number 6 TMDI card. TMDI being my is it TDMI or TMDI? TMDI. So let's click that. This is a T1 card. So I give it 106 because all my loops start at around 100. That's just what I decided to do. I give it its address. It's media gateway card. It's not asking for the MG card. It's asking for the card that you're going to be using for this digital trunk interface, this DTI loop. 24 voice or data calls because this is a T1, not an E1. If it was an E1, it would be 30. As you can see, since this is in T1 standard, it only lets me do 24. To hook everything up to the Cisco Cube, this is what you have to use to interface with the Cube. You need extended superframe. There's different formats, but ESF is what you need. Your mode of operation is PRI, primary rate interface mode. You check the box that says it's a TMDI card, because otherwise it's going to think it's a DTI card, and that's not a DTI card, even though it is technically a DTI card. 0 on the transmit equalization. Line code is B8ZS. Yellow alarm method is just how you do yellow alarms. Your threshold, I don't even know what the fuck that does, so I think that's a threshold on errors. I don't really care. It doesn't really do anything for me. So we leave it at 0 for now. I'm going to hide the phone. We're going to hit cancel and go back. Different types of loops that are available. So you can add a whole bunch of different loops. You can have multiple conference loops, multiple conference loops. You can even have 2 megabit DTIs and 2 megabit PRIs. Those are for your E1 connections. So if you're European, you usually get your stuff as E1, which is I think 31, or is it 30? I think it's 31. So it's 30 data channels, 30 B channels, and 1 D channel. Anyway, these are all the loops that I need for what I'm doing. A tone and digit switch for analog and TDM sets, digital sets. MG conference for those two as well, and a DTI to hook into Penis. So, then we're going to go over to super loops. Super loops are, think of them as like I was saying, a container. So, the super loop type that we have of 4 is displayed as I showed you on the MGC. It says 004 on my MGC. That's basically telling me that this shelf is super loop 004. So we go into super loop 004. Hello. Can I? Guess I can't click that, even though it's underlined. Oh, there we go. So you're given a bandwidth zone number for your shelf. So shelf 0, shelf 1. We do not have a shelf one because we don't have an expand. Well, we do have an expansion. See, it's right there, but it's not in service because I don't have a power supply. You put in your ELAN address, which is your equipment LAN address. Equipment LAN is Nortel lingo for basically something that the customer, it's not the customer facing LAN. The customer facing LAN is the TLAN. They are physically separated. We don't do any kind of VLAN. Well, it's technically VLAN. We don't fuck around with VLANing and shit like that. It's just ELAN and TLAN. So, on the front of the card, the MGC has two connectors. One that goes to the ELAN and one that goes to the TLAN. TLAN is where everything on my network T-marks, basically. So, on my home network. So, like, if, let's say, the IP phone. The IP phone interfaces with the TLAN, not the ELAN. ELAN is really only fucked with internally. It's also the internal LAN. Whereas the TLAN is the external LAN. Now we've got this one that says virtual. And we're like, huh, what's virtual? Virtual is used for the IP network. This is used for Unistim. What the fuck is it called? Unistim? I don't remember. The proprietary Nortel IA IP set. Shit. IP set. What is it? Protocol. That's the word. That's what that's used for. It's for interfacing with nodes and stuff like that, which we'll go about in a little bit. MSDL MISP cards. We don't do any of this. This is left alone. Everything is a conditional download. So this allows me to download stuff to the cards, but all that stuff is handled in a different window. I don't use this link. Conference, TDS, multi-frequency cards. We don't do anything in there either. Tone senders, you have to have a digitone receiver. So, if, for some reason, you do not have your digitone receivers defined, some things won't work. So here you've got this terminal number 000004015. 15 is just an arbitrary number. It's a virtual card in the in shelf 04. So when you add a digitone receiver, you just put in a terminal number and you add as many as you want. Normally you need 8 of them. So I've got 8 of them here, and you see I can move it to different terminal numbers. We don't want to do that. We're going to skip that. Alright, peripheral equipment. Companion law is always set to mu law. These timers here allow you to edit the time of, like, what the dial pulses are, interdigit timers, flash, hook flash, so like how quick if you need to do a flash on the hook, what you have to wait for. The rest of this stuff is just default. Alright, we go to IP network, we go to nodes. So we're opening up IP telephony, and then what we have here is, this is what we use for IP sets and IP phones. So anything IP is done here. And so you see node ID in this. You have to associate a signaling card. You have to set up all of this stuff, SIP line, terminal, gateway, stuff like that. This stuff will allow you to do SIP within the IIA, which I decided not to do. Instead, I decided to not do SIP gateway, even though I have SIP line. I don't really do that. I just didn't want to deal with it because it's a little more difficult. So I instead pushed everything down to T1 and let Cisco handle it because there was more documentation on the Cisco side than on the IIS side. So I made it easier on myself. Anyway, all you really have to know for Node is that you need to give it an IP address, you have to synchronize it, and you have to give it certain components and enabled applications to allow. Oh, shit. Let's try to get that again. Components, servers, and cards. What does that fucking do? Oh yeah, it just adds the signaling server on there. So the signaling server acts as the host for these things. Maintenance and reports, I don't really jack with that. Media gateways, this is where you define your media gateway. So when you come in here originally, you will add your IPMG here, put in all of this stuff. This is default here. You put in your bandwidth zone, which you define elsewhere. And then here you go is, this is your MGC configuration. This is your DSP configuration, which what you need the DSPs for is if you are calling between an analog TDM set. Well, no, you don't need that for an analog TDM. You need analog. Yeah, yes, you do. Digital, you dumbass. It transcodes everything from analog to digital. So if you have any analog sets, you need DSPs. DSPs are found on your MGC, and they are daughter boards. They have to have their own IP address and their own host name so that they're accessible by the devices on the TLAN. It's basically like your media server address. You point your shit at it and you throw your encoding stuff at it, and the DSP comes and does the digital signal processing to turn it into analog or fuck with it however. Zones. So you need zones. You need a bandwidth zone to basically say you need an MO zone and a V-trunk zone. So an MO zone is, what is MO? What was the MO zone? I can't remember what MO stands for. You have to have one of each. You have to have an MO zone and a V-trunk zone for it to work. A V-trunk zone just is something that allows you to put IP stuff on that zone. I'm skipping numbering zones because we don't really give a shit about routing calls through a centralized call server right now. Routing is handled with routes. Host and route tables. I don't think we're going to be doing any of this either because this is doing more networking shit. This is more SIP stuff. Yeah, no, don't touch this. The rest of the stuff I haven't touched yet. There is a personal directories thing that I may actually play around with later, but not right now. Interfaces, we don't really do anything with that yet. I have not touched application module link. Don't know what value-added server is, but let's see what that is. Application module. No, I don't know what the fuck that is. Emergency services, we don't jack around with that. The only thing that we have for emergency services is access numbers and routing, which we have a 911 number here. because you have to have one. So customer 0 does have the 911 emergency services number. That is so basically if you dial 911 on any of these sets, it should just jump onto the Twilio trunk and make a 911 call. It's not working right now because of dial peers and dial peer fuckery. I will fuck with that later. Because I will need to call the city to let them know that I'm doing a 911 test call so that, you know, I don't piss off the workers at the PSAP. They're usually pretty chill when you tell them it's just a telco test call. If they have time, they'll even read you back your E911 information. But, you know, I don't want to take up 911 bandwidth. Software, we don't really fuck with either. Oh, that's where you do IP phone firmware. Huh. Cool. So if I find new firmware for this shit, I can just upload it here. There are no signaling servers present in the IT. Yeah, you're full of shit. Anyway, we're gonna collapse all this shit because it's the first time going through these things. A lot of this stuff, you don't gotta touch, it just works. So we go to customers. One of the first things you do when you create your IIA system is customers. So customers has, you just put in garbage numbers. Different features, stuff with ISDN, your local codes, your features, zipline service, timers, night service, class of service, attendant, call redirection, party name display, stuff like that. Information. Customers basically allows you to multi-tenant this thing and kind of shard off who owns what within the system. Okay. So, next up is routes and trunks. So we're going to go to routes and trunks. We've got a couple defined. So this 200 tie trunk right here that has 30, these 200 TNs, TN meaning terminal number. This 200 trunk right here, we're going to go in here. This is what a IP trunk looks like. So, it knows that it's a V trunk. It knows that its zone is 2 because it's a V trunk route. The reason why it's 200 is it matches my super loop, my virtual super loop. We put in the node ID here that ties it together. These are all of the different interfaces that have to match up. What it looks like is that it's basically a virtual T1. So other than that, we skip that. That just works. Let's look at the Myrans. So I have 2 Myran 8 cards. Well, or what are they called? Myran 3 cards. I have 2 MC8 cards flashed with Myran 3, which is the Meridian integrated RAN, whatever the fuck RAN means. But basically what it allows me to do is allows me to dial 750, do that, or not. I guess I changed it. I think it's 500 now. What's the fucking access code? Well, let's just do this. 450. Allows me to do this. Well, it's supposed to be playing fucking music. But it looks like that there is no fucking music right now. For some fucking reason. For some reason, there's no music. I don't know why. It could be that it's interpreting those 452. 452. Okay. So my music trunks are broken. Yay! We'll fix that later. Anyway, what those basically do is when you dial a certain DN, or transfer somebody to that DN. Ugh, holy crap. It'll just play music for them. Network music, this little checkbox in here. Right there. Will assign it for music on hold. So that when you hold somebody, it basically transfers them in the background to that extension, monitors for you to let them off hold. When you let them off hold, it transfers you back. Is basically what is going on there. Route 106. I've entered this route at least 50 times. So we're gonna go in here and look at this one. This is a very important route. This has to be exactly the way I have it to work on Cube. So this is the Nixtel route. So this route basically hooks into the extension system. Without this route and this T1, I cannot access and its associated trunks. I cannot access the Nixtel system. Alright, so as you can see, 23 trunks, because 23 B channels. And then we go to the D channel. 200, this is a DCIP D channel. This has to do with, this is more, it's just there, it's kind of a fake D channel, but it's not, but it is. 106, this is what it has to be for Cube to work. And then we're going to go look at, see, we've got DTI here. You don't really go in here to change anything. ESN. Really what you have to do here, this is where you go change your network class of service if you want to do class of service. We don't do class of service with Laptel currently. This is where you go change your this is where you change your DN length, your NARS bars code, everything you really need to do routing. Now, so you're thinking, okay, so how do you get to the other trunks? Well, how do you get down to the other carriers? Well, what you do is you define. We've got the route to Nixtel, to the core. We've got the route that goes to the Cube and then translates to SIP to connect to the core. So it basically comes down pots. It gets transcoded on the Cube to SIP, to a SIP protocol from an ISDN protocol from POTS line. down to Nextel. So how does it know which way to go is the question. That's what we've got steering codes for. Local steering code, we have 7.5 as a, oops, or not, 7.5.5, I guess? Oh, no, we don't actually use local steering codes anymore. Since I use a 7-digit DN, the 7.5 doesn't have to fuck with steering codes. At some point, if I ever add another exchange, like 7.5.6, I will have to then add a steering code 7.5.6. A local steering code. Distant steering codes, I think, is what we use for... Yes, distant steering code is what we use for telling it, when you enter this code, take this route. So this one knows that when I hit 6.9, it knows that I'm going to take route list 10, which route list 10 corresponds to route 106. Eventually, it's going to respond to route 106, route 107, and route 108, which will be two other routes that are going to come off of the second TMDI card, so that I have failover. So if one of my TMDI cards just decides to die, I have two more trunks on the other side, and a clock controller to take over. So that entire card could be removed from the system. And then the other card should just take over. So I have a steering code for every carrier code in the Penis extension system. As you can see, 7 digits. We don't do any kind of manipulation. And then it just goes to route list 10. Route lists are found in the RLB. And as you can see here, we go in here and we go to the data entry index, which is the attached route. This one shows here that, you know, all this information is pretty much standard. We're not doing any digit manipulation. We're not doing any other kind of stuff like that. We just cancel that. It's going to try 5 times. But it's going to go down route 106. I can add more data entry indexes. I can add 64 of them, actually. So each route list block can have 64 entries. So if I had linked cabinets and I had 64 T1 connections for some fucking reason, I could have 64. How many T1s could I have? Because T1 is only 4 lines. So that's 2 pair. That's 2 pair. I could have... divide by 2. 12 T1 lines per car. Why would it be 13? 12. Because you have to have orange, white, orange, blue, white, blue. For T1. Anyway. We continue in the electronic switch network. We don't mess with the numbering plan. We just mess with the CDP, the coordinated dial plan. Network attendance services, that looks like that's going to be something that we'll get to start using when I get the Palm Pilot online. We will have a video for the Palm Pilot when I actually dive into it and start fucking with it. I just need to get access to it to reset some passwords, config some IPs, and go from there. Since it's basically a server on a card. It's a double wide card that hosts a really shitty fucking Celeron processor that does, I think Copilot is the attendant and voicemail. I can't fucking remember. Doesn't matter. Anyway, flexible code restriction. We don't really do any of these. As you can see, it's blank. ID's T, incoming digit translation, IDC. We have some. We have a tree, but we don't do any of that. Phones is self-explanatory. You kind of just enter what type of phone you want. I do it through customer. The way that phones really works is it's done by customer and TN. So a TN is a terminal number that is its address, basically, on your punch block, or if it's a virtual loop like 200, as you can see here, we've got 004s, which are physical, and 200s, which are virtual. Those are all the DNs and the different types of phone. 500 is an analog set. The M series are digital sets. These right here are IP, and that's a WLAN set. Alright. That's pretty much it for the CS1000 tour. Now, we have to talk about Cube. Ugh. Which will be in the next video, because I don't feel like doing a Cube video right now, because Cube makes me want to die. So I will leave you with this.